So again, welcome everyone. Today we are in part 2 of our data calculations series, I guess, just two of two here. Last week we went through a few different transformations, kind of introduced them in general, how we create a new column of data, some calculated data from whatever assessments we've had. And then we did some examples with subsample assessments, control corrections like your Abbott's calculation, and user formulas. So today we're just kind of picking up right where we left off and covering some other types of calculations that are possible in ARM. And specifically, we'll look at rating scales. Number one, just kind of how to enter them, how you can enter them in ARM, as well as the calculations we can draw out from assessments like that. We'll look at our yield conversion tool and area under curve, or things like the area under disease progress curve, your AUDPC as well. So with that, just like last session, we'll kind of go back and forth between a PowerPoint that kind of summarizes and introduces each of these topics. So we'll kind of talk about the theory, and then we'll switch over to ARM, see the calculation in action, maybe walk through the steps of creating that calculation in my example trial that I have loaded up for us. All right, well, let's dive in here to our first topic, which is rating scales. And again, kind of start just with a real basic introduction. At least in ARM, kind of categorize this as two different types of scales that can be entered in, because EPPO has a list. They've defined some standard scales that they've went through the process of defining for certain, pest and crop combinations, and they have a certain set of rules, parameters around them, and so some of our calculations and things in ARM kind of are geared specifically for these types of rating scales. The biggest common denominator of all of these scales, they all start with 1. 1 being the lowest scale value with no incidence of that pest. So I have a couple on the screen that I just grabbed from EPPO's website just to kind of show the types of things they have. So the first one, the idea of if you're evaluating an insecticide product, then your pest crop combination here would be for beets. Looking at your soil pest complex, how many lesions are on your beet, and so you'll notice that they try to look at that crop and the pest and categorize them. And so then we have this simple scale, the assessment value itself. You would rate the plot as a 1, a 2, a 3, or a 4, or maybe in this case a particular beet, and you might do it several times. As to what category does it fall into. And same thing here with fungicides on blue mold of tobacco. And so you're just trying to put in a category. And so they've went through the science part of what is a reasonable category to make this scale reasonable, logical, because you can tell the size, as far as how many percentage fit into each of those categories definitely is different. And so instead of trying to, you could certainly record just the raw percent if you wanted to, but here they're trying to encapsulate meaningful cutoffs and ranges that are meaningful in that system, or in the analysis and the conclusions you might want to draw. So that's kind of one of the advantages here, and that's also then maybe easier to rate. as well, that you don't have to be quite as precise. You're not asking an individual to know the difference between 10% and 15% area infected if you were making them put in that specific number. A little bit easier to have that whole category of here's kind of your range, anything, this is a 5% and this is a 25. So if you see anything in this range, that's what a number 3 looks like. A little bit easier to rate as well. So that's the setup here, the idea if you're using those types of scales. So then, how to enter this into ARM, at least as far as the calculations that we have in ARM, try to match the EPPO guidelines for how they lay out you should record and enter the data. And so this is kind of the process that they've laid out. You would create a separate column in ARM for each class, for each scale level that we had. And so that way, the assumption is that if you're working in a plot and maybe you have 10 subsamples that you're performing this rating on, what we would do is count up of these 10 subsamples, how many of these fit into category 1, which in this case would be no incidence. So how many of my subsamples fit into this category? And so we have 2 of them fit here. And then in my example, 2 of them fit into the next category, and so on and so forth. And so in theory, if you summed all of these up, they should equal the total number of subsamples that you took. So instead of just writing down, this is a 1, this is a 2, this is a 1, we're counting how many end up in each of those categories. So depending on the size, how many different scale levels you have, you might have quite a few assessment columns to enter that in, but the data entry itself is reduced. There's only that many values. So instead of having to enter in 10 values, 1 for every subsample, in this case, we only had to do 4. So that's the general setup, the assumption here, and how you would enter in that data. And so a couple of calculations that we can do for these scale ratings. The first one is incidence. So ARM can calculate a percent incidence, essentially, what percent of your subsamples had presence of that pest. So again, the assumption is that a scale of 1, the value of 1 is no presence. And so thus we can calculate, basically we just add up all of the others, how many were in 2 through whatever, and then how many, and then we sum up, the grand total, multiply it by 100, so it's a percentage. So we can use this DIP, and then we'll see the list in ARM of those. But you just can type this right into your ARM action code, or we can pick it from the list. We'll do that in just a moment to see how to enter that, but that action code creates this calculation. So it will give us the percent of the subsamples that had pest present. So kind of handy knowing that ARM can calculate that for you. You don't need to keep track of that when you're taking the data. Is one advantage, instead of kind of trying to keep tabs on that while you're taking the data. The other calculation we can do is to calculate the index, or really the severity of the infestation. And really the idea here is to not just count up how many subsamples had some sort of pest. Let's factor in the severity, the intensity of the infestation as well. So the calculation here is we're really creating a weighted calculation. So you multiply however many were in, were ranked as 2, multiply that by 2. And how many were 3 gets multiplied by 3. So, as you get higher, as the severity worsens, it's carrying more weight in this calculation. And then you divide by the total to get this weighted average, essentially. If it's a worse, then it should count for more. And so that would be your index or your severity, which is column 14 over here in this corner, our pest severity. So we can arrive at that calculation as well. So let's switch over to ARM and just see that in action here. So this is my EPPO example. Should be pretty similar to those screenshots. But I've got column 10 through 13 was where I entered in the data. And the idea here, our assessment is leaf damage, we'll say, and we've got those 4 categories. And in this case, I think that's what I did. My part rated was, we're rating the leaf damage, specifically how many are in category 1. So the action I performed was counting, and the unit is number. How many of our samples fall into category number 1? In this case, the no incidence. So that's kind of how I enter that in here. So given that data for our, our 1 to 4 scale here, then I've created these calculated columns. And the key, just like we saw last week, this ARM action codes field has a lot of calculations that we can create. And so I'll bring up this list so we can see that we do have a section in the action codes list. The list is very, very long, so we try to put in these little category markers here. This isn't a real code, but it kind of helps us separate. All of these following ones are calculations for the EPPO 1 to N rating scales that we showed just now. So we try to cover just every combination, 1 to 2, 1 to 3, all the way up to 12, I think. Yep, we can go all the way up to 12. And so in our case, we did the 1 to 4. We're going to calculate the index here. I think that was in the title. Yep, calculating that index, the severity for us of a 1 to 4. And then this N we replace with whatever is the source column that we want to calculate our data from. And in this case, you can see in the description, well, there's really 4 columns we're going to want to utilize. We don't have to type all 4 numbers in because ARM knows and is assuming that you're going to put all 4 of those columns right next to each other. They shouldn't be separated by anything else. Otherwise, we're going to grab the wrong information. So they should all be, category 1, 2, 3, and 4 right next to each other. Then all we have to do is tell ARM where the first one is. So in my case, I said I start with column 10. That's where my category 1 is. ARM will find all the rest of them and perform our calculation. If I select this from the list, you'll just see ARM will actually ask us. So we can get this little interface. What column should be used for this code? So if you're creating this by from scratch here the first time, you might see that if you want to pick from the list, ARM will just kind of guide you. Hey, click on whichever column, or you can type in the number. Column 10 is the basis for this calculation. And so there we get that. Have that code, which gives ARM the instructions on calculating our index values. I was like, wait a minute, that didn't look right at all. Our code here for the EC 1 to 4 for our calculated values. So that was our pest severity. Very similar idea here with the pest incidence. Just a slightly different code, the DIP instead. And so this will calculate percent incidence for those EPPO scales. Kind of in the same area of our list, just underneath the index scales, we have the pest incidence. And this is a percentage, so nice and easy as far as that goes on what the unit is. Okay, so again, we're kind of making the assumption with these EPPO type scales. Certainly, if you're using some other kind of rating scale, doesn't have to come from EPPO, but if you're doing a 1 to something, and that 1 means there's no incidence, no anything there, you can use these same calculations. Definitely not, the calculations themselves aren't specific to EPPO and that system or their scales. They, it certainly can be used for other ones as well. You just would want to utilize this structure for entering in your data if you want to utilize these types of calculations. All right, there are certainly other rating scales out there. And we have calculations for ones, presumably the other type, I guess, would be if your scale starts at 0 instead. So anything with 0 to some number, we can calculate very similarly an incidence and that index and severity. We're just assuming that 0 means there's no incidence, there's nothing here. Whereas before that 1 meant nothing. So these calculations, in addition to supporting the 0 as your starting point, you can enter them in just in a single column, and you just would have subsamples. So my example of I've got 10 subsamples. We're just going to put in those scale values just as I record them. This sample is a 0. The next sample, well, that's a 2. This next one's a 1. Well, we're actually entering those values in just as subsamples. So fairly straightforward as far as the setup of how it's entered. Obviously, kind of depends on how many of those values you have to record. If you're taking 200 subsamples, that previous system's probably better. You don't have to try to enter in 200 values and try to keep 200 straight before you move to the next plot and hope you put them all down. Easier to count them up. This one, maybe smaller sized sampling, works nice and neat here just to record each individual value. So again, we've got codes very similar in structure, but you'll just notice instead of 1-4, it's 0-4, but the same idea. Calculate a percent incidence. What percent of my samples are not 0 in this case? And then that index severity to give a weight to each of those of how bad was the infestation there. And then I do have one more type of calculation. It's the Townsend-Heuberger calculation, and that's really taking this index. So it is a severity type of calculation, but making it into a percentage. So maybe a little easier to compare, across studies or different sampling sizes or whatever. This one is coming in as a percentage, but just a severity percentage, really. And let's go in ARM to see our list there. So just starting here real briefly, we've got our assessment, trying to tag how much damage to the plant from a 0 to 3 scale. And I've got those 10 subsamples. So let's look at 10 different plants across our plot to get a sense of the damage that's occurring. And I just recorded the scale value for each of those plants. And then our DI is our percent incidence for subsamples up to 0 to 4. Technically, it works for all the smaller ones as well. Same thing here, but with our severity, so DS, disease severity, for the 0 to 4. And then this last one here is our Townsend-Heuberger disease scale from subsamples. So again, that is a percentage, kind of in that same area. I'm just scrolling up so you can see they're all in this same section of our action codes, if you're trying to look for it. Also can utilize the filtering. So if I wanted to find that severity or that incidence, but I'm not real sure, I don't want to just scroll through this list endlessly, just right click in the description column and you can do a filter for. And so if I'm trying to find that incidence calculation, I don't remember what that code was specifically from the webinar, you can just search for that word. And now ARM will shrink down this list to only show us codes that have that specific keyword in the description. Now it's a lot easier to find that calculation that we're looking for. All right. Any questions on the rating scales? Very good. And I can share. There was one question about the website to those EPPO codes, and I can look that up here. If I have a minute at the end, I can send in the chat. Otherwise, I can send out an email when we send the recording. I might make a note of that URL to just where in EPPO they have all those different rating scale ones, like the examples I had. So we'll look that up here. Okay, next topic here is yield conversion. So this kind of has its own special tool for us to take your raw yield, the weights that you get from your harvesting technique, whatever they may be. You've got raw yield values, and we want to, of course, calculate those into a standard per area basis, because then you can actually compare that to any other trial, and your standard yield amount of whatever area basis that gets compared to, instead of just the amount you have from your one small plot. Doesn't mean anything to anyone, but when you start talking about tons per hectare or bushels per acre, suddenly people know what that means. So kind of an important function to be able to do, and ARM can calculate this for you. Just looking at this dialog before we'll actually step through it in a moment, but you can see that you first list off the existing data. What unit do we have in ARM already? Then what are we trying to get to? What's our target? And if your target is in bushels per acre, you can enter in your test weight as well. And ARM has some crops in its memory to help you fill that in. Then, of course, we need to know the area that was harvested. So we need that in order to figure out and standardize. So it fills in by default your plot width, what you have in your trial settings. Of course, that's not always the case. Maybe you harvest just the middle two rows or whatever. Maybe there's some issue with certain areas of the field, so you couldn't quite harvest the same exact size for every single plot. It is possible to kind of tweak that amount. You can either, if it's the same size for every plot, it's just different than what you had in settings, you can change it right on the dialog here. You could also put in the width and the length of the harvested size as columns within your trial. And that's the way to kind of work around that, differing harvest sizes for different plots. You can just put in the literal size that you did harvest for each plot just as assessment columns. And then you can turn this option on so ARM will look to those columns in order to calculate your plot size plot by plot. So each one of them could have a different size if you needed to. So, oops, trying to allow some customizing just depending on the situation that you're in. And of course, the unit, that also comes from settings too. So that's kind of how we adjust to whatever plot size we have. There is also a moisture adjustment that we can make. So if you want to adjust to a specified dry moisture percent, you can enter that in right there. This also fills in from the trial in your crop description. If you have a value filled in, that links here. Then you can point ARM to a particular data column. I think that's the most common thing, to have different moisture values for each plot. It usually comes in right with the, all the combine data has your weights and also the moisture. So you can just point ARM to the column number where that is, or if you just have an average percent you want to calculate as the basis, you can fill that in. And the whole time you're changing this, and we'll see this in a moment, I'll run this in ARM, this conversion factor gets updated. And that's really kind of ARM showing us, hey, as you're tweaking the settings, this is that conversion number I'm going to end up with that we will use to multiply the raw values to make it into our yield in a per area basis. So let's go back to ARM and look at our yield example. So kind of the most common here is to have that raw weight here. I've got it in kilograms from my plot, and then I also have that moisture percentage for each plot as well. That just came from my equipment. Then what we can do is take those two values and calculate a yield. So I've done that here. I've got my tons per hectare. And what happens after you run that, we get this TY2 action code. So last week we did some user formulas, and Let me see if it even shows in this list. Did some user-defined formulas, and when you created your own formula, ARM just saves that in the trial itself, and it calls it T1 for the very first one you create. And then if you make another formula, it's just known as T2. Real simple naming, just so it has a a real basic code that it can put in the header. But behind the scenes in the trial itself, there is the decode of T2 is actually this formula. It's the exact same thing here with the yield, but the code just has the Y for yield in it as well. So this is transforming the yield, and how many of them have I created in this particular trial. So the downside there, kind of a common question though, then is, especially if maybe I'm the sponsor receiving this trial from my trialist, what did they do? I'm not quite sure what all went into this calculation. If you have a column already converted for yield in ARM, go ahead and click in that column. And then if you go to the Tools menu, as if you're going to go and convert the yield, that can at least give us a head start on guessing as what they did. So here you can see we've filled in, it's already been filled in column 6 and column 8 to show us kind of what happened. Now, not everything gets saved, so you can tell we don't have everything filled in here just because of the way ARM performs the calculation. In the end, it's this yield conversion factor that really is utilized. So we didn't automatically fill this in, but of course we can deduce clearly kilograms was the source, but I can see in this header that we had tons per hectare. So we can kind of deduce this, even though ARM in its in memory didn't save that choice in the trial. It's not too hard to kind of reverse engineer it if we kind of wanted to know that part. But it will show us the harvested plot size if they had used specific columns or not. Here we look like we used our regular plot size that we have in settings, because these are turned off. And that dry moisture percent, and we used, again, the moisture that's in column number 7. So that's how we take that there. This is column 7 is where I should look to use the moisture. So that's the yield conversion process. Let me just show maybe from scratch. So that was maybe I did this in reverse of how to know what an existing yield conversion is. You would just perform, you would act as if you're going to perform it, but in that column where that calculation is. If you're the one that wants to create it, maybe I'll just create another one here in column 30 just so we can see what happens. You can just start in your raw weight assessment you have, and then it's the same tools, convert yield. And ARM can guess at your current unit if you have the picked from the list. It can see what the existing unit is, and then we can just go through that process of selecting what unit we want to convert to. I did just want to show if I select bushels per acre, then these options get turned on. So just for those that might be doing bushels per acre, if you know your test weight, just go ahead and type it in. But ARM has a few of these crops listed here for guidelines or estimates on the test weight. So if you're not totally sure, that's really what the crop here is listed, and it'll just change that test weight value because a common one for tomato would be 53. But certainly if you know yours, this doesn't even have to get filled in. You can just type in the test weight that you have for your trial. Again, only specific to bushels per acre. If we were going to replicate our tons per hectare that we did in column 8, that option's irrelevant. It gets grayed out and it's not used. Plot size, again, we can adjust that. So if maybe I only do the middle two rows, I'm doing that backwards. If it was the rows, then I'd maybe cut the width down in half and the length would stay the same. And then that dry moisture percent, that does get saved in the trial. So I'm going to change this to 14 so we can see where it updates actually in the trial as linked to our crop. And then we'll adjust based on column 7 again. Let's put it into 30. So since I've changed a couple of things, ARM is just going to confirm. I've tweaked a couple of pieces of information. Should those changes be reflected in the trial itself as well? So here I've got that harvested width. Well, previously we had 1.1, which kind of matches our plot size, but ARM can document specific for our harvested width in the site description. It would make sense. So I'm going to say, yes, I want that documentation saved there. And same idea for our percent standard moisture. That information is saved in the site description. So if I've changed that number, or in this case, entered it, ARM wants to at least give me the opportunity to make sure that that is documented correctly in the trial. So I'm going to say yes to that as well. And before we get too far, let's just go into the site description to see those pieces. Working backwards, that percent standard moisture is right there in my crop description. And then the harvested width and the harvested length, those values are here in my crop as well. So we've updated those pieces of information. Again, it is just a little different than from our settings where we have our treated plot size. So it is certainly possible to keep those two separate. And actually, it looks like my example, we already had half the width. So I'm now only doing one row, I guess, instead of the two. We already had the harvested size smaller than our full treated size. So that's kind of that linkage there to document some of that information. And so we were on the yield example. And so we have our calculation here where we've just about doubled, not quite because of our moisture adjustment, but just about doubled since we did cut that size in half. Essentially, then we're pretending that we have twice as much in our plot than what we did. So that's why those numbers are different than what we had already, is because we tweaked the moisture adjustment and then also the plot size. It's kind of the biggest difference in the numbers there of why this is different. One note here that kind of matches the comments where we saw we can't quite reproduce that entire yield conversion dialogue just based on what ARM actually saves as part of the transformation. that very same reason, the yield conversion calculation doesn't get saved in an SE. So if you consider the fact that, hey, these 3 columns are really nice, I do this same process again and again in most of my trials, it'd be nice to repeat that, to save that, so I don't have to do these steps every time. That's really what standard evaluations, or SEs, are good for. And for, I think, really all of the other formulas that we've done, the rating scales earlier today, and all the formulas and calculations in the last session as well, they all end up getting saved as an action code. And so the SE can save that information as well. So you can really set up the calculation once, create an SE file that includes that calculated column, and then you can reuse those descriptions in all of your trials. And then that calculation just fills in as soon as data gets filled in. So it's really nice to be able to incorporate those in an SE. The only thing is this yield conversion currently does not work in an SE. So all the rest of these would, other than the yield conversion, just because of all of these parameters that go into the calculation. Not everything has a home, has a spot that can be encapsulated into that one formula. Because the next trial I run might have a completely different plot size or different moisture. There's just so many things that are somewhat trial specific. We can't just bring it all together, roll it all in, and it's the exact same formula every time for these yield conversions. So just a word of warning, the yield conversions specifically don't roll up into SEs very well, but pretty much everything else does. Okay. Last topic here is the area under curve. Kind of a generalized name. For years and years, we had just one of these in ARM called the AUDPC, area under disease progress curve. But then, of course, we got feedback, hey, it's not just the disease people that do this type of calculation. So we've generalized it, added some options in ARM, so that way we're not specifically calling disease, because certainly this stuff can be done in a lot of different types of research. But the idea here, the setup would be you have ratings that are repeated. Specifically going to go out and take a stand count on our weeds, take an assessment on how much the disease is right now in the field, whatever pest we are monitoring. Let's go out time and time again at hopefully regular intervals. My setup here is every 2 weeks. Doesn't really matter what the schedule is, as long as there is a schedule. The more regular, as regular of intervals as you can get is kind of the best setup for this. And the idea is that, sure, each one of those assessments tells me something. Right now, things were bad in these plots. This treatment did not, wasn't doing a good job, while this treatment was. But of course, as the season progresses, those rankings can change. Oh, well, suddenly now this treatment's really come on and it's controlled a lot now, and this other one's kind of starting to fall off, and things are getting out of control here. So the question can be, how did time factor into the performance of my products? And it's just hard to get that from just a just looking at the numbers or trying to run the analysis on each of those assessments individually and trying to like keep track of all of that. It's not very easy. So the idea with this calculation is let's create a weighted total of the response that we saw for each treatment across that time frame. And that would be something useful to compare to each other. That would be useful comparison so I can see overall how well did this treatment do compared to this other treatment across the range of time. So, mathematically what we do is kind of break up, if it just imagine, here's our graph of the different response points for each treatment. So I've kind of shaded them in where really calculate the area. We can get our geometry out and calculate the area under this curve. That would give you a sense of what the response was. And we add up each of these boxes, add up that area altogether, gives us this weighted total of factoring in not just the response at one given time, but then the duration of the response. And we do that for each treatment as we go, and then we can compare that total to each other to tell us over that stretch of time, this treatment, in this case, this red treatment did the best. It has the smallest value, so it controlled the most, whereas the green product here maybe has the largest total, and so did not do as well. Or if this assessment was flipped and this is our percent control, totally opposite story, of course. The green did fantastic. Just depends on your type of assessment, which direction you'd make that comparison with. So let's go to ARM here. So my example I stole just right from our tutorial set of trials, and it is an AUDPC, kind of the classical example with disease. Like I said, it doesn't have to be only disease. But I've got our assessments, just like we saw in that graph. Over time, we went out and performed our disease counting. I guess we're counting disease loci here. What percent on our plants or something to that effect across these different time frames. So once we have those data in, looks like I have just a percent. That doesn't seem like that's what I want at all. Maybe I just filled in the wrong column there. I don't think that's supposed to be in our AUC at all. There we go. So we've got our 4 assessments, and then we have our calculated AUDPC, which again, just the area under disease progress curve. So let's actually just run that. Let's create this calculation. So that'll be under Tools and Transform. And I'd like to start by clicking into the first column that I want to transform. I wouldn't have to, but then it just saves time later trying to pick out what column number I care about. And for this example, then I'm looking at this section of our transformations here, our area under disease progress curve, the AUDPC. Like I said, we also have added just a very general area under curve, literally the exact same calculation as far as under the hood, the math behind it, they're the exact same. But this just provides an option to kind of get rid of that term disease If that's not the type of research you're doing, doesn't make sense to have that reference. But mathematically, we're doing the same process here. We do also have a standardized AUDPC. So it's just the very same idea where we calculate that total, and then you just divide it by the number of days. So then that's useful to compare in different trials. Suddenly you can use this value outside of this one trial because it's standardized per day. So that way another trial that might have had a different date range, you can compare those two still. So that'd be the reason to utilize that. But I'll stick with just our regular AUDPC calculation. I'm going to start in column 22, but we'll see in a moment there is a little interface for us because we want, of course, multiple assessments. We want to include all of this repeated assessment in our calculation. And we'll just put it in column 31 to see the new calculation. So when I click OK, we have a little wizard that's going to come up. Essentially, we want to be able to pick up all of the repeated assessments. And so what ARM is doing, certainly we could, kind of like the other transformations, just give ARM a list of column numbers. Real straightforward, just here are the 4 that I've done. That's what I want you to use. But ARM can be a little bit smarter and actually pick up any columns that are in this pattern. And that's what we're doing up here. ARM looked at that source column. I was clicked into 22 when I started this process. So it's going to look at the description of column 22 and try to guess the pattern. Based on this assessment, what should I look for in other columns to know that they're the same type of assessment? So it's utilizing the rating type in that column 22. I'm going to scroll so we can find those, put them side by side here. So that source column we started with was column 22. The rating type and the rating unit is a great place to start for knowing this is the same assessment. So anytime we do disease count in %, that's a good clue that that's the same type of assessment as we've done. Taking it a step further, it also looks at the pest code, because maybe I have several different pests that we're monitoring, and I certainly wouldn't want to combine those together. They should stay separate. So that's what ARM has come up with to discover and find the columns that are the same. And as such, it's found 22, 23, all the way up to 26 are ones that are the same. Which again, I've got to review my one here because this doesn't quite seem right. So I'll have to review my example because he doesn't seem like that is supposed to be there. But anyway, we'll ignore it because my description certainly matches. So it would appear to be that way. I can adjust this. So if I need a little more nuance to it, I can definitely do that. I don't really see much though that I can do. Maybe the action code. Essentially, we're defining a filter, if you will. So I can click on this gold dropdown and it'll show me all of the unique ARM action codes that have been of the columns that are selected. So in my mind, I'm trying to get around some of these that maybe I've already created a calculation, and thus the description of that column ended up maybe a little too close, a little too similar to the real description, and I really don't want to include that. Doesn't look like it's letting me just take the blank. I was kind of hoping maybe it would. But this would allow you to tweak a little bit if you needed another field to add, perhaps. But again, I don't see much that I can do here since I've kind of messed up this extra column. So we'll ignore it and pretend that that data we want in here as well. So the idea is really to make ARM smart enough to know what to look for. And the advantage then is I can set up this calculation right away at the start of the year. I could set this up in my protocol, or I guess to send with my protocol, I'd need to put it in an SE because we can't transform things in the protocol. But anyway, I could set this up right in my trial at the very beginning, and then the calculation will just continue to expand as assessments are added, because it's going to look specifically for columns that fit this specific type, I guess, if you will. So when I click OK, now we calculate this AUDPC. It comes in as a user formula, and we've got these values here. And again, the value itself doesn't mean much. You know, this 1755 doesn't have like a real world use to it. You wouldn't just tell someone, well, the average of treatment 5 was 1700 AUDPCs. You know, it doesn't have a clear unit, but it is useful to compare to each other. So you can compare the average of treatment 5 versus the average of treatment 4. We can see treatment 4 has a much lower response compared to treatment 5 over the course of time. And so that's the type of conclusion that we can draw. And real quick, I want to show this T6 transformation. It is this AUDPC function. So by going through the wizard, ARM filled this function in for us. So I didn't have to hand write this, but I do just kind of want to point it out as kind of a drawback to our, or a callback, excuse me, to our advanced user formula functions that we talked about in the last session. It's got this AUDPC function, and all you have to do is give it column numbers, and it'll calculate the AUDPC. But because we use the interface to craft that query, if you will, it has embedded this match function. So it's looking to find all columns where the rating type is COUDIS, disease count, and the rating unit is a %, and the pest is this specific pest code. So we're kind of leveraging two different functions within here. And so as we add, if we were to perform another type of this assessment, so if I needed to go out one more time to do this disease count, I can still have my AUDPC in place. And then, oh, my view is making this harder than it has to be. Oh, I did not do a good job of pasting. Let me try that one more time. Let's take one of these descriptions and paste it here real quick. You know, we're kind of running a little short on time. But this additional assessment later on in August, whenever, as I start putting in data, it's refreshing. So it's auto calculating, which is fine because I kind of want to show that this number is changing because ARM has found this additional assessment that we added in. So the AUDPC can continue to expand. So you could get the calculation set up in a trial even before you send it to the trialist. And then they can just, as they add more and more assessments as time progresses, that AUDPC will just keep refreshing itself to take into account those other assessments. Okay, fast and furious, but we did get through all of our topics. Well, I thank everyone for joining us. I do have one question here, but I don't want to hold anyone hostage. So maybe we'll see you again at some of our future webinars. If you have one more minute, there is one question here about doing the same transformation on data that's already transformed. So certainly any of these calculations, ARM doesn't particularly care if the source column is calculated or not. So like you said, if using our scale example where we entered in all of our rating scale information, we calculated our incidence or our severity, you could certainly take that severity calculation and use it in another calculation. ARM isn't going to prevent you from doing that. So maybe you want to do a % of check on that severity rating or something like that. That most certainly would be possible. So we'll just use this example. Well, no, let me use the EPPO one because I actually have all of the data filled in. Pest severity, I can go tools transform and have column 14, this calculated information, that can be the basis for another calculation. No problem at all. I could do an Abbott's on that, and ARM will let me do so. So yep, you can definitely stack and grow. ARM doesn't care. So, all right. Well, thanks everyone. And hopefully, like I said, we'll be seeing you maybe at a webinar in the future.
Thank you very much. Bye.